Hey everybody, so let's do these problems. Alright, so the first do it yourself says if sine of A is 1 over square root of 5 with A in quadrant 1, find sine of 2A, cosine of 2A, and tangent of 2A. So first, since we're in quadrant 1, my triangle is going to look like this, meaning that the actual axis itself is here, and I'm in quadrant 1. So sine is opposite over hypotenuse. So opposite is 1, hypotenuse is square root of 5. That leaves us to find this missing piece, which I'm going to call A. So A squared plus 1 squared is equal to square root of 5 squared. A squared plus 1 equals 5. A squared equals 4. So that means A equals 2. Now it's positive 2 because we're in quadrant 1. So that means that this value here is 2. Which means that they already told me that sine of A is 1 over square root of 5. So that means that cosine of A is going to be 2 over square root of 5. And with that, I can figure out these three things. So the first one is sine of 2A. Oops. So sine of 2A is 2 sine of A cosine of A. So 2 sine of A. Sine of A is 1 over square root of 5. Cosine of A is 2 over square root of 5. And remember that this 2 is really 2 over 1. So if I do all the multiplication, top times top times top, I get 4. Bottom times bottom times bottom, I get 5. Now I have cosine of 2A. And you can use whichever of the three formulas you want. I just usually stick to my cosine squared A minus sine squared A. And so this is going to be cosine squared. So 2 over square root of 5 squared minus sine squared, 1 over square root of 5 squared. And so this gives me 4/5 minus 1/5, which is 3/5. And then to put it all together, tangent. I'm just going to do sine over cosine. Sine is 4/5 over 3/5. The 5's cancel. And you're left with 4/3. So there you go. Sine, cosine, and tangent. Again, you could have used the formula for tangent. You could have gotten the exact same answer, the 4/3. So, I'm going to pause real quick. Unexpected stuff. Alright guys, sorry, I'm trying to multitask and it's not going very well. Alright, so anyway, that's that problem. So let's go to this next one. Now this next one, there's a typo. So if it's written as it is, you would say no solution and you'd be done. Because if you try to make a triangle with what was given to you in quadrant 3, secant is the opposite of, or sorry, the reciprocal of cosine. And since cosine is adjacent over hypotenuse, this would be hypotenuse over adjacent. But notice that this doesn't make sense because the hypotenuse can't be the shortest side in a triangle. And so that doesn't work. So that's a typo. The real thing should say, and I'm going to try to fix it and put the fixed version on line before you download it. But it should be negative 13 over 5 is what it should have been. Right? So here I have theta. So if it is negative 13 over 5, we have hypotenuse, which is 13, over adjacent, negative 5. Now this is a 5, 12, 13 rectangle. And since we're in quadrant 3, this means this is negative 12. Again, you can use the Pythagorean theorem to figure that out. All right, so we're in Q3. with this triangle, I know that, and again, Q3 means that here's the quadrant. Quadrant 1, quadrant 2, there's quadrant 3, there's quadrant 4. Anyway, I know that sine of theta is opposite over hypotenuse, so a negative 12 over 13. I know cosine of theta is negative 5 over 13. And then tangent of theta is going to be 12/5. Right, so now I can figure out all the other terms. So cosecant, I'm just going to find sine first, and then I'm going to flip it. So this is 2 sine theta cosine theta. 2 sine theta is negative 12 over 13. Cosine theta is negative 5 over 13. Remember that this is a 1. So here I have, let's see, 10. I have positive 120 over 169. So I can go to the next one. Oh, sorry. That's actually not the answer yet. And then I flip it. And that gives me my answer, cosecant. So 169 over 120. Next one. Now I go to the secant, and I'm going to do the cosine. And I'm going to flip that one. So cosine is just cosine squared theta minus sine squared theta. Cosine squared theta, sine squared theta. So 25 over 169 minus 144 over 169. So when you type those in your calculator, you get negative 119 over 169. And so if you flip that, you get the secant. So secant of 2 theta is negative 169 over 119. Remember, you keep the negative on top. Kind of wrote it a little wonky, but this is where it flips. Okay, and now for the last one, since I use sine over cosine, I'm just going to go ahead and use the formula just to do it both ways. So tangent of 2 theta is equal to 2 tangent theta, 12/5, over 1 minus tangent theta squared. So that's 12 over 5 squared. So here this is 24/5 over, I have 1 minus 144 over 25. And then that's 25 minus 144. I did that already. That's negative 119. And I can fix this. So 24 over 5, I can multiply that by 5 over 5. And that gives me 120 over 125. Over 25. And notice that the 25's cancel. Again, you can just type this in your calculator and math bracket. I'm just going over the whole thing. So this is negative 120 over 119. But then again, we flip it, and that gives us cotangent. Negative 119 over 120. There you go. All 3 worked out. Okay, cat sleeping on my keyboard. But now let's go and let's see if we can figure out some of these proofs. So again, I apologize for the typo. I'll try to fix it before I post, or it's already posted online, but I'll try to post a fixed version. All right, so now proof time. Prove the following identities. The first one says sine squared theta equals 1 minus cosine 2 theta over 2. And let's work with the more complicated side and see what we get. Cosine of 2 theta over 2. Excuse me. And really it's up to you on which of the, remember cosine of 2 theta has 3 different forms. Now since the answer is sine theta in the textbook, or sorry, not in the textbook, earlier on the previous page, I went ahead and just did cosine minus sine squared. I'm going to try a different formula, just change it up. Since my answer has sine in it, I want the answer that has sine in it. So I'm going to be 1 minus, and then the formula was, always forget that, 1 minus 2 sine squared of theta. So the minus distributes, and you get 1 minus 1 plus 2 sine squared theta over 2. 1 minus 1 cancels out. 2 sine squared theta over 2. The 2's cancel out. And then you're finally left with sine squared theta. Yay! Identity proved. So that one was pretty easy, hopefully. Let's do the next one. Same thing here. This is 2 cotangent of 2t equals cotangent t minus tangent t. I'm going to go with this side. And so cotangent is just the flip version of the tangent. So I'm going to get the tangent formula, and I'm going to flip it. So this is all the same thing. So the flipped formula would be 1 minus tangent of t, tangent squared t, over 2 tangent t. Notice the 2's will cancel out. You're left with 1 minus tangent squared t over tangent of t, and it's pretty much done. All you got to do is divide everything by tangent. One over tangent is cotangent. And then tangent squared over tangent is just tangent. And there you go. Yay! Fun, happy proofs. Well, I think all proofs are fun and happy, but you may feel differently. All right. So now let's go to the next one. Oh, they're showing Rick and Morty on TV right now. Oh, it's that episode. Okay. Anyway, this last one. So this one I'm going to, again, go with the more complicated side. And let's see where that takes me. So the first thing, or first let me rewrite it. But then I want to use the formulas for sine. Sine of 2x and use the formula for cosine of 2x. Before I do any of that, though, let me factor out that 2 because that's just sticking out. Oop. All right. So looking at this, I have 1 minus that cosine. You can go with either of the formulas, any of the three. There's really no right way to know it. And chances are that, the three formulas are pretty similar. And you can actually get from one to the other just by doing an extra step. So even if you choose the not optimal one, it's only adding like one extra step to the process. But anyway, I'm going to use cosine squared x minus sine squared x, but this has to be in parentheses. And someone's blowing up my phone. I'm going to go check that in a bit. So sine of 2x is 2 sine x cosine x. All right, so this is going to distribute. Notice the 2's here will cancel each other out. So I have 1 minus cosine squared x, double negative, plus sine squared x, over sine x cosine x. Now when I was first doing this and working on it on my own, I was like, hey, look, check that out. That's sine squared. And I went throughout the whole process and I actually found an answer, but it wasn't the answer they were looking for. Notice the answer they're looking for is 3 separate terms. It's thing 1, thing 2, thing 3. I notice in the numerator I have thing 1, thing 2, thing 3. So this is one of those cases where I got an answer, but it wasn't really the answer they wanted. So I had to backtrack. But anyway, from here it kind of solves itself. This is 1 over sine x cosine x minus cosine squared x over sine x cosine x plus sine squared x over sine x cosine x. Now 1 over sine is going to give me 1 over sine is cosecant, 1 over cosine is secant. So that's where I get the secant x cosecant x. Here, one of the cosines cancels out. I'm left with cosine over sine. That's cotangent x. Here, one of the sines cancels out. I'm left with sine over cosine, which is tangent x. And there you go. All right, so hopefully you did okay on those. Let's go to the very last one, and then we are done with this. So this last question says, if x equals 5 tangent theta, write the following expression in terms of x. So the first thing you do is you rewrite it. Tangent theta is x over 5. So tangent theta, tangent is opposite over adjacent, opposite over adjacent. And so this means that the other term, which I'm going to call, is 5 squared plus x squared equals a squared. So usually we write it with the x squared first. So x squared plus 25 equals a squared. And then we take the square root of both sides. Since it's the hypotenuse, we keep the positive side. So a is equal to the square root of x squared plus 25. And now I can figure out all the stuff. Now that what they want me to find is this. Okay, I had to click on it like 5 times. So here I have theta over 2 minus 2 sine theta cosine theta over 4. That's just 1/2. So theta over 2 minus sine theta cosine theta over 2. So that's just 1/2 theta minus sine theta cosine theta. So this one's pretty nice. Notice that it just has a theta in it, which I'm going to use the inverse of the term they gave me. So for this theta, I'm going to use the inverse. Really? I'm going to use the inverse of tangent. Now for the sine and cosine, I'm going to use my triangle. So from looking at the triangle, I can see that sine of theta is x over the square root of x squared plus 25. Cosine theta is 5 over the square root of x squared plus 25. And now I'm just going to fill them in. 1/2 parentheses. Theta is going to be inverse tangent of x over 5. So that takes care of him. Now the other one are these two. So minus sine theta so x squared plus 25 cosine theta 5 over x squared plus 25. There you go. And so the two denominators, you can see that it's just the same thing squared. And so my final answer is minus 5x over x squared plus 25. That's it. So there wasn't a lot of crazy simplifying like there was in the previous one. I just wanted to work it out both ways. Not both ways, but I wanted to... I'm rambling. I'm trying to watch Rick and Morty on one side and then I'm... Yeah. Anyway. So on a test, as far as difficulty goes for this problem, that's really what you're expected to see. When will I see this again? You'll see this again when you get to Cal 2. Okay, in Cal 2, you're going to be doing antiderivatives, and they're going to say, find the antiderivative of this guy. And you're like, oh my god, that looks so nasty. But if you go backwards and use a triangle, you can turn it into a trig function, and it ends up looking a lot nicer. And then it's just taking the antiderivative of this. So you will see it again. All right. Anyway, have a good one, and yeah, y'all got this.